go ahead and have us work with that, but they're going to give us more information, kind of what I was explaining to you in the previous slide. So evaluating expressions. When evaluating the expressions, you must follow your orders of operation, your Pemdas, right? So please excuse my dear Aunt Sally. We still have to use in this. So where do roots come into play in that Pemdas? Because I say nothing about roots in there, right? Well, square roots are the opposite of exponents. So remember, if we had 3 squared, that's an exponent right here. That's the same as the square root of 9. Gives me 3 or 3 squared, right? So roots and exponents are opposites of each other. So they're going to fall on the same level. So when I go to solve these, I'm now going to have to understand that if I have square roots, those are going to be solved whenever I would solve an exponent, okay? I also want to go through to help you understand how to read these, because I know sometimes it's confusing when they start throwing in that square root. What does that mean? Well, when you have a number that's sitting outside of the square root with no symbol right here, that means that you're multiplying. It's the same as when we used to work something like this. Okay, we know that when there's no symbol right there that we're going to multiply. It's the same thing when you have that radical symbol. Or that radical symbol. You're going to go ahead and multiply when there's no symbol. Okay, so we're going to go ahead and follow our Pemdas. So Pemdas, please, our P is parentheses. I don't see any there. My next is my exponents. Now remember, this is also my roots. So do I have any roots in there? I do right here. So I'm going to go ahead and solve that. And I like to put it in a parenthesis when I solve it so that I don't forget to multiply it, because that's a very common mistake is kids will write down the number, or even adults. They'll write down the number and then they just mix it with that 5. I have to remember that I'm actually going to multiply. So when I find the square root of 36, well, that would be 6, because 6 times 6 is 36. I'm going to put that in a parenthesis, and now I'm going to bring everything else down. Notice how I just brought down the 5, and I brought down the plus 7. Okay, so I'm done with my parentheses. I'm done with my exponents. Now I'm going to do any multiplying or dividing. So remember, these are left to right if I have both of them involved, which I don't. All I have is multiplication here, so I'm going to go ahead and do this part. 5 times 6 is 30. Bring down my plus 7. I'm now down to just my adding and subtracting. So 30 plus 7 gives me 37 for a final answer. Okay, steps. We're working those steps. Some of you are very comfortable with Pemdas, and some of you need to slow down and take your time. Okay, we're adding roots in there. That's something new. As I've worked with many of you on orders of operation, this is where people tend to make their mistakes, is that multiply, divide. They think they always have to multiply first and then divide. But remember, if you have more than one of those operations, you work left to right. Same thing with adding and subtracting. If you have more than one, when we get into more complex problems, you work left to right, okay? All right, let's go ahead and try another one. Okay, so we've got 12 minus 3, and then the square root of 25. So Pemdas, parentheses, I don't have any. Exponents, which is the same as roots. And that should be a visual. That square root symbol should be something visual, like, oh my gosh, I have to do that first. Okay, unless there's parentheses involved. So I'm going to go ahead and solve this. So I'm going to bring everything else down. 12 minus 3. And then I put my answer in a parenthesis so I don't forget to multiply it, because that's how I'm used to seeing it. So the square root of 25 is 5. Okay, 5 times 5 is 25. So now I'm going to go ahead and move on. I've done my parentheses. I've done my exponents. I now do any multiplying or dividing. I see multiplication here. So I have 12 minus 3 times 5 is 15. Okay, so now I move on to that adding and subtracting. So all I have is subtraction here. Remember, you guys are going to be working integers. So I have 12 minus 15. Okay, some of you are comfortable with these and some of you aren't. So I have to remember, okay, that's a positive 12 and a negative 15. Those are different symbols. So I'm going to find the difference, which is 3. The larger number of 15 had a negative sign. So my final answer is negative 3. Some of you are comfortable with those and some of you aren't. So maybe try it and then check it on a calculator. That final step. Check that final step on a calculator, okay? But I do want you practicing those integers. Okay, I want you guys to try this one. Okay, so this time you do have a parenthesis. So you're going to go ahead and solve everything that's inside of that parenthesis first, still following the Pemdas. So go ahead, pause your video, Work your way through this one and then check yourself. Okay, you should have gotten negative 15 for this one, remembering following those orders of operation. This time I had a parenthesis, so because I had more than one thing, that's why I circled it. It's more visual for me. And then I thought of this square root of 49 minus 10, I thought of as like a separate problem, and then pieced it back in with that 5 that was on the outside. Okay. Okay, so that's working with some just basic ones. Now we're going to go a little bit more advanced, and that's where they're going to give us the fractions. Okay, I know that you don't like fractions. We're going to practice these. When I assess you on the final assessment, I will give you ones where maybe you're just simplifying radicals like that. Okay, but I won't give you the multi-step problems. I want you to practice them throughout the lesson and as you do your practice work, but I will not assess you on those. Okay, so when we go through to do these, we've got 1/4 plus the square root of 18 over 2. So 18 over 2, I could go through and simplify those, but here's the one thing I do want to tell you. If you can see that within this, you can reduce the fraction, you need to do that. We have not practiced the square root of 2. That is not a perfect square. It's going to, if you check it on your calculator, it gives you like 1.4142 da 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 da. You guys haven't worked with anything like that. So anytime you have a fraction, your first step should probably be to check, can I reduce the fraction first? Sometimes you can. So when I look at this, 18 divided by 2, can I do that? Yes, I can get 9. So now this is what I'm looking at, 1/4 plus the square root of 9. Okay, so now if I find the square root of 9, well, that's 3, because I'm following orders of operation. I didn't have parentheses. I simplified my root to a square root of 9. So now I'm going to solve that. That's in this exponent part, which is 3. And then I still have 1/4 out here. Whoops. Okay, so 1/4 plus 3, or 3 plus 1/4, is going to give me 3 and 1/4. Key thing to remember when you do this, if you get a really funky number within those radicans when we're solving fractions, go back and double check yourself. Could I have reduced it? Okay, right now we haven't worked with those, what they are called is irrational numbers. The square root of 2 is irrational. We haven't worked with those. So if you're getting a really long decimal number, that should be your first indicator. Right now, I did something wrong. Okay, oh yeah, maybe I have to go back and reduce. Okay, so let's try this one. So ask yourself first, can you reduce that 28 over 7? Can I reduce that down? Okay, so let's simplify that. Can I reduce this down? Yes, that would give me 4. So now I've got the square root of 4 plus 2.2, or sorry, 2.4. Okay, so my square root of 4 is going to give me 2 plus 2.4 gives me 2 plus 2.4 is 4.4. Okay, now these are going to be very basic. I will probably assess you on something as basic as this, but I promise I won't give the fractions in like a really, really long orders of operation problem. Okay, but I will give you some that are as basic as this, where we're getting some pretty easy numbers to work with. Just to see, are you understanding to reduce that fraction first? Okay, so here's a story problem 1, and we're going to work through this one together. Okay, once again, you should be practicing the concepts that I'm doing on the board. If you're not practicing those and you come across them in your homework, you're going to need to come back and rewatch the video. So it's just easier to practice them. Even though I did the last 2 with you, you should be practicing those. Just watching the video doesn't mean that you understand it. Okay, so the area of the circle is 2,826 square feet. Write and solve an equation to solve for the radius of the circle. Okay, so we're going to use 3.14 for pi. We need to jump back to stuff that we learned back in 6th grade and 7th grade, and that would be, how do we find the area of a circle? pi r squared sounds like area to me. So area of a circle equals pi times radius squared. So we're going to plug in all of the information that we know. Okay, so do we know the area? Yes, it's right here. So our area is 2,826. I'm going to then put my equal sign. Do we know the pi symbol? Yes, they want us to use 3.14. And then times our radius squared, which I don't know that part. That's what they want us to find. So now if I want to get that r squared by itself, right? Because remember, this is now going back to algebra, solving for a letter, okay? So I want to get that r squared for now by itself. So how am I going to get rid of that 3.14? I'm going to divide it. So I'm going to divide this side by 3.14. So that's gone. Now I'm left with r squared over here. But whatever I do to one side, I have to balance the equation and do to the other side. So over here, I have to do 3.14 divided by that. Okay, so we're going to punch in on our calculator. 2,826 divided by 3.14. And when I do that, I just got 900. So I need to now finish this out. This is where lots of times people will make a mistake and they'll say, well, the radius is 900. But remember, it was the radius squared. What number times itself gives us 900? So remember, squared is the opposite of square root. So to find my final answer, I want to find the square root. Because really to do this, I'm square rooting to get rid of that squared. So then I'm going to square root on the other side. So the square root of 900 is 30. So I just found out that r, the radius, equals 30. And I could go back in and plug that into my original equation and put 30 here. So then I would do 3.14 times 30 squared, okay, which would give me 900. And if I punch in 900 times 3.14, it's going to give me my 2,826 on my calculator. So this is my final answer. Okay, so I want you guys to go ahead. I'm going to give you one of these. I want you to go ahead and try it out. So right now, it's basic substitution. I'm going to give you that equation. I'll rewrite the equation. But you're going to have to understand that. That's something that you have previously learned. So this time it says the area of the crop circle is 45,216 square feet. What is the radius of the crop circle? So to find your area, it's area equals pi r squared. So you're going to substitute in this where area is, this where your pi is, and then solve to get r by itself. Remember, you want to get it to just be r, not r squared. So you're going to have to do that square root in your final step. So go ahead, pause your video and work through this one. You should have gotten r equals 120, and then our label would have been feet. Okay, pretty complex. They're just giving you higher end. On this one, I won't give you something like that on your assessment, but it may be something that I have you practice on homework. Not to say that you're not going to come across those things on Iowa assessment or STAR. So I want you to practice them. I'm going to focus more in class on the basic square roots and understanding how to simplify those. So remember, as you're working through square roots, you're finding what number times itself would give you that number under the radical symbol or the radical symbol. We will be going through and actually then be working with some orders of operation. So remembering that when you do Pemdas, that your E is where your square roots would fall into place, okay? So good luck with this one and just keep plugging away. It's a new concept. Yes, you can use your calculators to help you out, but you need to just continue to practice.